In lecture 2, we will review the electronic states of molecules. And because as we've already mentioned here, light is made of the electric field and magnetic field, but mostly electric field is going to interact with the molecules, but not directly the molecules. Each molecule has electron crowd, which is literally like cloud of electrons. This cloud can, since this cloud is made of the electron, it can interact with the electric field, and which oscillate the electron crowd by, and at some moment it can induce a photochemical reaction. And as I mentioned, the light itself doesn't have not much parameter, and only the wavelength and intensity can be controlled. But there are so many varieties of chemical reactions because there are many varieties of the molecules, molecular structures, meaning the different shapes of the electron clouds, that provides varieties of photochemical reactions. So the key point is we have to understand the photochemistry or photochemical reactions. We need to understand the electron crowd, meaning the electronic states of molecules. So let's start from here, which is an example of ethylene case. So let me remind again. So interaction between the light and molecules is the interaction between the light field and the electron crowd, and not so many variations of the electric field, but you have varieties of the molecular structures and the molecular and electron crowd. So let's think about at first ethylene case. And if you are a chemistry student, everybody knows that ethylene are in the same plane, so flat structure. And some of the students misunderstand that this is because sp2 hybrid orbital. And most of the chemistry students know that the molecular orbital of carbon is made of the sp2 hybrid orbital, which is directing toward the triangle directions. That's the sp2 orbital. And these sp2 orbitals make a bond with a counterpart of carbon and 2 of the hydrogen. And similarly, the second carbon also have sp2 orbital and making a bond. They are XY in the XY plane. However, the reason why they have a flat structure is not due to the sp2 orbital. And you may notice that these carbons have another p orbital. So some remaining the p orbital in this configuration, pz orbital. And these pz orbital make another bond called the pi bond. That's since the electron crowd of the pz orbital looks like this, you cannot twist the carbon angle between the carbon-carbon angle because there's some strong bond here, and this prevents the twisting motion of the carbon. This is the reason why the ethylene has a flat structure. So let's coming back here, and let's start from the review of the hybrid orbitals. And as you may know, as probably chemistry students know that the sp start from sp3 orbitals. So carbon has in the carbon 2s orbital and 3 2p orbitals, and when they are mixed 4 sp3 orbitals are formed, right? So which is called a hybrid orbital. And probably many of you don't think the reason why they make a hybrid orbital, and let's think like this. So the important thing is literally that the electron cloud is like a cloud of electrons, meaning the cloud is very soft and squishy, so it can easily change the shape. Then the key point is these electron cloud can easily change under each environment. In this case, the sp2 or sp3 orbitals are made because probably most likely the 4 hydrogens are nearby. So this carbon wants to make a bond to make a shape of the molecules. That's why the electron cloud, so electron cloud, it's a very flexible electron shape. It can be changed into the 4 direction to make 4 bonds with hydrogen in this case, for example. So this is a reason why the hybrid orbitals are formed, because to make 4 bonds, this carbon needs 4 orbitals or 4 electrons to make a bond. And thinking about the electron configuration of carbon, you can see the 1s, 2s, and 2p orbitals. And originally, 1s is occupied, 2 electron occupied, and 2 electron occupied 2s. And so since carbon has 6 electrons, so it has extra 2 electrons here. Right? And when this carbon wants to make 4 bonds, the easiest way is the making a mixture of this 2s orbital and 3p orbitals to make 4 orbitals, and then electrons are located at each of the orbitals, and then it's ready to make 4 bonds. That's a configuration of the electrons